All right. Hi, everyone. I just wanted to briefly go over the whole entire point for this lesson. The point of the lesson is to create an energy level orbital diagram. Okay, so I'm going to just reset all of this right here. Right here, we've got these tabs. Okay, and the first tab is a detection of the photons that get absorbed during the emission of the laser. That absorption, remember, is reflected on the spectrum. So if 3 is absorbed, this would be the 3, or this might be the 13, or whatever the number is. That's what these lines on the spectrum mean. Okay? So when you are on the photon detector display, any that are missing, that means it was absorbed, and any that are here means it went through. Okay, so if it went through, that would be the rest of the colors here. The goal is to connect the absorption spectrum to the energy levels. That was the goal of this again. So when we go over here to the energy level, right here it says show energy of emitted photons. Okay, so that's what is emitted, right? We want to note, for this instance, these particular levels are noted for where those energy levels is for gas A only. Okay, gas B is different, and the mystery gases are different. So if that's where the energy level is, where does the absorption take place? That's what this goal was. So when I fire, I see that there was some absorption right here going from 2 to 4, and then there was some absorption going to 2 to 1. If I take the difference between these energy levels, 8 to 16, which is going to be 8, well, it's going to be actually 9 because it tells me right there, that is the area on my EV color diagram that had the absorption take place. And the same thing here, between 16 to 20, that's 4. So it's giving you what it is. So that tells you that when you add up 9 and 4, you get 13. My output is still 13, which is the amount that I inputted. Okay, but it was seen at different levels within my energy diagram, and it would also be seen at different levels within my absorption spectrum. Okay, again, let me just say this one more time. When I emitted my laser, the values that are going to be here are going to be my amount that gets my amount of the energy. Okay, again, 4 and 9 equals 13. That is the relationship between them. Energy in equals energy out, but it doesn't always lie the same. Okay, so that's one thing. Then when it asks you to switch over to the lamp, what goes on here in the lamp portion of it is very similar. What you get is you get a series of numbers. Those series of numbers, if we were to compare it to an absorption spectrum, is all these visible lights that we can see, not the dark lines. But if we take out where the dark lines are, which we can see 4 is missing, we can see 13 is missing, right? 1, 2, 3, 4, 5, and 7 is missing. That is going to correspond to our lines on the emission spectrum, where they would be dark. Okay, so that's the relationship there. I don't know if this is going to be helpful to the questions for you to answer, but I do hope that it is helpful to the overall connection of the purpose of the activity. Remember, this is not going to be due until we get back on Tuesday from break. So if you have a moment, play around with it. Otherwise, on Wednesday, I will be reviewing the first few minutes of class, again, the overall goal. Thank you and have a wonderful weekend. Bye.